The Huntington Hill method was first proposed by Joseph A. Hill in 1911 and later on refined by Edward V. Huntington. The Huntington Hill method, also known as Huntington method or the Hill-Huntington method, is a mathematical approach used for apportionment, dividing a set number of seats. This method ensures a fair allocation by using a geometric mean to determine when a state or group should receive an additional set. The Huntington Hill method is a mathematical approach used for apportionment, which means dividing a fixed number of sets among different groups based on their population. It is the official method used to allocate sets in the U.S. House of Representatives. So the key features of Huntington Hill method are: it assigns at least one set of every state or group. It uses a priority system to distribute the remaining sets fairly. It is based on the geometric mean, which helps balance representation between large and small states. It eliminates a problem like the Alabama paradox, where a state could lose a seat when the total number of seats increases.
Here are the steps. First, assign at least one each state or group. Second, calculate the priority value for each state or group using the geometric mean formula, which is priority equals the square root of p multiplied by the quantity p plus 1, where p is the current number of seats assigned to the state or group. Third, allocate the remaining seats one by one to the state or group with the highest priority value, updating the priority values after each allocation. Fourth, continue the process until all seats have been allocated.
Problem: apportioning seats using the Hungtington Hill method. A country has 5 states and a total of 50 seats need to be allocated in the national legislature based on population. The population of each state is given below. State A has 3,200,000 population. State B has 2,400,000 population. State C has 1,800,000 population. State D has 1,200,000 population. And lastly, State E has 400,000 population. Using the Hungtington Hill method, determine how many seats each state should receive.
Step 1. Assign at least one seat to each state. Each state must receive at least one seat for representation. State A. Population is 3,200,000. Initial seat is 1. State B. 2,400,000 is the population. Initial seat is 1. State C. Population is 1,800,000. Initial seat is 1. State D. Population is 1,200,000. Initial seat is 1. State E. Population is 400,000. Initial seat is 1. So total seats assigned is 5. Remaining seats is 45. Step 2. Compute the standard divisor and lower quota. We calculate the standard divisor by total population divided by total seats. So total population is 9 million and total seats would be 50. So 9 million divided by 50 is equals to 180,000. Using this, we compute each state's quota by population divided by 180,000, which is the standard divisor. So state A, 3,200,000, the quota would be 17.78 and the lower quota is 17. State B, population is 2,400,000. Quota is 13.33. Lower quota is 13. State C, population is 1,800,000. Quota is 10.00. Lower quota is 10. State D, population is 1,200,000. Quota is 6.67. Lower quota is 6. State E, population is 400,000. Quota is 2.22. Lower quota is 2. So the sum for lower quota is 17 plus 13 plus 10 plus 6 and plus 2 is equals to 48. Since we need 50 seats, we must assign 2 extra seats. Step 3. Allocate extra seats using geometric mean. To decide which states get the remaining 2 seats, we use the geometric mean GM equals square root of P multiplied by P plus 1, where P is the current number of seats a state has. A state gets an extra seat if its quota is greater than the geometric mean. Computing the geometric mean for the next seat. Each state starts with its lower quota. Then we compute the geometric mean for the next seat. So state A, lower quota is 17. Then square root of 17 times 18 equals 17.49. Then quota is 17.78. Then repeat the same process for state B, C, D, and E. So state B, lower quota is 13. Then geometric mean 13.49. Quota is 13.33. State C, lower quota is 10. Geometric mean is 10.49. Then quota is 10. State D, lower quota is 6. Geometric mean is 6.48. Quota is 6.67. State E, lower quota is 2. Geometric mean is 2.45. Quota is 2.22. State A gets an extra seat because 17.78 is greater than 17.49. State D gets an extra seat because 6.67 is greater than 6.48. Final step is seat allocation. Now the final seat distribution is State A, final seat is 14. State B, final seat is 11. State C, final seat is 9. State D, final seat is 8. And State E, final seat is 1. So total is 50 seats assigned correctly.
After applying the Huntington Hill method, the 50 seats were distributed based on the population of each state. The state with the highest population, which is the State A, get the most seats, 14 seats, followed by State B with 11 seats. State C and D were also fairly represented with 9 and 8 seats, while State E, having the smallest population, received 1 seat to ensure it still had representation. This method uses the geometric mean to determine when a state should get another seat, making sure the distribution is balanced and proportional. It also prevents unfair situations like a state losing a seat just because the total number of seats increased. Alabama paradox. So since this system prioritizes fairness, it is even used in the U.S. House of Representatives to divide congressional seats among states.
So what we learned from this reporting is that the Huntington Hill method is a mathematical approach used for apportionment, ensuring a fair distribution of a fixed number of seats among different groups based on their population. Originally proposed by Joseph A. Hill and later refined by Edward V. Huntington. This method is widely used, including in the U.S. House of Representatives. It works by assigning at least one seat to each state or group, then distributing the remaining seats using a priority system based on the geometric mean. This prevents unfair situations like the Alabama paradox, where a state could lose a seat when more seats are added. By applying this method to a real-world example, we see how seats are allocated proportionally, ensuring fair and balanced representation for both large and small states. Thank you so much for listening. This will be the end of our discussion for Group 6, and the last is the definition of terms.
Huntington-Hill method is a mathematical approach used for apportionment, ensuring fair allocation of a fixed number of seats among different groups or states based on their population. It uses geometric mean and the priority system to distribute seats fairly. Apportionment. This is the process of distributing a fixed number of seats in a legislative body among different groups or states based on their population. Alabama paradox. It occurs in apportionment when increasing the total number of seats results in a state losing a seat. The Huntington-Hill method eliminates this paradox by using the geometric mean to ensure fair allocation. Geometric mean. This is a type of average that is calculated by multiplying all the numbers in a data set together and then taking the nth root of the resulting product, where n is the total number of values in the dataset. In the context of the Hungtington-Hill method, it is used to determine the priority for allocating additional seats to states or groups. Priority system. This refers to the process of calculating and assigning additional seats based on the geometric mean, ensuring that seats are distributed in a manner that balances representation between large and small states or groups.